Okay, very good evening, everyone. Now we are going to start acceleration, and which is the new part of our chapter called motion. So first we had to understand acceleration. Okay, so let's go through with the example. Aman, are you there?
Yes, sir.
Okay, so Aman is going to start, okay, by riding the bicycle. Okay, so here we have the road. Okay, here we have the road. Okay, and here we have now Aman. Okay, Aman. Okay, now Aman, when starts moving, okay, with the help of bicycle on the road, so on first second, velocity of Aman is like 10 kilometer per hour. Okay, 10 kilometer per hour. When he starts, like motion with the help of bicycle, its initial velocity is 10 kilometer. But on second, its velocity increases by 5 kilometers. So I can write 15 kilometer per hour now. Okay. After that, on third second, its velocity increases by again 5. So on third, its velocity is by 20 kilometer per hour. That means every hour, like every second, velocity of Aman's bicycle increases, right? So at what rate velocity is going to change is nothing but acceleration. Understood? At what rate velocity is going to change is called as beta acceleration. Understood?
Yes, sir.
Okay. So the rate of change in velocity. The rate of change in velocity is called as acceleration. Right? So let this is the final velocity. Final velocity. Let it is V is velocity. So let it is V2 and it is V1. So V2 minus V1. Okay, is called as beta acceleration. Understood? And at what rate, whenever we are like taking rate, so we have to divide it by time. So final velocity minus initial velocity divided by time is called as acceleration. Understood?
Yes,
Can you
sir.
explain again, sir?
See, suppose whenever we are going to ride the bicycle, or next another example. Let's go to another example. Okay, here we have, this is the earth surface. Okay, and here we have the tall building. Okay, the tall building. Understood? And you are throwing any object vertically down. Okay, so initial velocity of that object over here, let it is 5 meter per second. I'm just taking an example, 5 meter per second. On second, velocity changes by 10 meter per second because gravity is like attracting that object, right? On third second, we have checked velocity is changed by again 15 meter per second. Understood?
Yes, sir.
So for that particular instant, it is final velocity, or that it is final velocity. So final velocity is represented by V2. So V2 is what? 15. And initial velocity is V1 and it is 5. Right? So final velocity at what rate it is changed? Okay, we have to calculate now. So we have to like calculate V2 minus V1 divide by time. So V2 is what? 15. V1 is what? 5 divided by time. See, it is the first second and this is second. So we divide it by 2. So 15 minus 5 will be 10 divided by 2. So it is 5. That means 5 meter. Okay. 5 meter velocity is changing every second, right? Is it?
Yes, sir.
So can you tell the definition of acceleration again?
Okay. So I'm just going to write the definition. Wait a second, but I'm just going to slide the. Okay, so I'm going to write the definition for acceleration. It is represented by A. So the rate of change in velocity. Okay, the rate of change in velocity is called as acceleration. Okay, so therefore, according to the definition, acceleration means A equals to rate of change in velocity. And how we have to calculate the change? Final velocity means v2 minus initial velocity. Means v1 divided by time, because we are considering rate here, so time, and time is represented by t. Therefore, we can write A equals to v2 minus v1 divided by t. And again, one more thing, final velocity is also represented by v, and initial velocity is represented by u. So we have to write u here and v here. So let me make little change here. V and here u. Okay. Therefore, v minus u divided by t. Understood? This is the formula for acceleration. Understood, everyone?
Yes, sir.
Yes. Okay, so take a screenshot. Done.
Yes, sir.
Okay, now we have to understand types of acceleration. Okay, so for that I'm giving you one more bit. Wait a second. Okay, so here we have acceleration, change in velocity divided by time. Okay, so final velocity. Here we have final velocity minus initial velocity divided by time. So here we have formula v minus u divided by time, right? Is it?
Yes, sir.
Yes. So in the velocity of an object during a certain time period, then it is said to have accelerated motion. That means if any object with like acceleration, like velocity changes continuously, so it is called as accelerated motion. Understood? Accelerated motion. That means suppose if we are launching any satellite beta, right? When we are launching any satellite, okay, from the Earth surface, so its velocity all the time increases, na, up to certain height, right? Is it?
Yes, sir.
Is that motion is accelerated motion, you can say. If the velocity changes unequal amount in equal interval of time, then it is said non-uniform. Okay, so if like velocity sometimes changes, suppose if you are driving the bicycle on crowded street, so sometimes your velocity is going to increase, sometimes decrease, right? So it is called as non-uniform acceleration beta. Non-uniform acceleration. Okay. Keep replying.
Yes, sir.
Now types, very important. Okay. So we have three types beta. Positive acceleration, negative acceleration, and zero acceleration. Okay. Suppose train, or let's discuss about the rotation of around the sun. No, we want to have straight line motion. Suppose train starts moving from Hyderabad and it is moving toward the Mumbai. Okay, or Pune maybe, as I am living from pure city Hyderabad to Pune. So if the velocity of the train is fixed, means speed is not going to change, velocity is not going to change. That means in first hour its velocity is 50 kilometer per hour. Even in second hour, again velocity is same 50 kilometer per hour. In third instant, again 50 kilometer per hour. So its velocity is changing? No, na? Right?
No, sir.
That means V minus U divided by T will be. So V is what? 50.
50.
Yeah. U is what? 50.
50.
Divided by 1. So 50 minus 50 will be 0 divided by 1. So it is 0 only, right?
Yes, sir.
Yeah. So it is called as zero acceleration. That means if the
No change.
velocity, yeah, if the velocity of the object remains constant, then it is called as zero acceleration. Easy?
Yes. Yes, sir.
But suppose if first our velocity is 50, then second it is first hour 50, second hour 60, then it is 70, then 80. So it is increasing continuously, na?
Yes, sir.
When we start the motorbike, okay, in a straight line path, so we used to increase velocity slowly, right? Continuously, right?
Yes, sir.
So yeah, so here velocity is increases, that's why it is called as positive acceleration. Understood?
Sir, once again, can you
Yes.
tell that I didn't understand?
Okay, wait a second. Huh? Okay, suppose here we have any object, satellite launch vehicle. Okay, so we are going to launch satellite in this way. Okay, so this is the first distance, second, third, and fourth. Okay, so here velocity when like object moving above the Earth's surface. So initially its velocity will be less, right? Right? Is it?
How,
Yes,
sir?
sir.
Okay, its velocity
How?
will be less because it starts moving a bit. Suppose if you are moving from the certain place with bike, so at initial level your velocity will be less, na?
Oh, yes, sir.
Yes, sir.
But as time passes, every second you will like accelerate your bike. See, why do we call that accelerator? Because we can increase or decrease the velocity of the bike, right? That's why we used to call accelerator. Acceleration, that word came from the acceleration only. So let
Okay.
initial velocity is 10 kilometer. Then after like a few seconds or 5 seconds, again it becomes 20 kilometer per second, like this. So its velocity is going to increase continuously, right? Every second. So it is called as
Yes, sir.
positive acceleration. Positive. But suppose if velocity remains constant, first hour 50 kilometers, second hour again 50 kilometers, third hour again 50 kilometers. So it is not going to change. So it is zero acceleration. There is no change in velocity. Okay. But if any object, if we are like going to suppose if you are applying the brake, okay, means you are on 100 kilometer per hour speed with your bike. I'm just taking example. Huh? Don't ride your bicycle or bike with that speed. Huh? And you want to stay somewhere. So you will reduce your velocity slowly, right? After 100, it will be 90, then it is 80, then 70, then 60, then 50, right? So here at every instant, you are going to decrease your velocity, right? And then you will become zero, certain place when you want to stay, right? That means you are
Yes, sir.
reducing the velocity, so it is called as negative acceleration. Understood now?
Okay, sir.
Yes.
So when
Yes, sir.
when
So
the
when you're
Yes, when you are increasing your velocity, it is positive acceleration. When you are decreasing
and
the
when it's
velocity,
going down, it is negative.
negative, yes. But if it remains constant, then it is
Then it is
zero.
zero.
Yes. You got the point now. Understood, everyone?
Yes, sir.
Yeah. So I want you have to take a screenshot one by one. Wait. Yes, here you take the first screenshot. Done.
Yes, sir.
Okay. From here, second one.
Yes, sir.
Okay, let's discuss from the notes now. An object can have positive or negative acceleration. When the velocity of an object increases, the acceleration is positive, right? And when velocity is going to decrease, okay, when velocity of an object decreases, it is called as negative acceleration, right? And in the direction positive, no, opposite to the direction of velocity, okay, velocity of an object does not change, means zero acceleration. Easy.
Yes, sir.